All right, so last class we reviewed factoring. Today we are going to use factoring to actually solve some quadratic equations. So in order to do that, there's a property called the zero product property, which we have to understand to understand how we're factoring. So the zero product property just tells us that if we multiply two things together and the answer is equal to 0, then it means that one of them has to equal 0 or they can both equal 0. Okay, so that's the only way to get 0 by multiplying, is either one or both of them have to be equal to 0. And that's going to help us because of the way we factor, we're factoring into two products or sometimes three products. So for example, here you can see we have two products. So we have x minus 2, or two factors, x minus 2 and x minus 5. They're being multiplied together and equal to 0. So using the zero product property, what that tells us is either x minus 2 is equal to 0 or x minus 5 is equal to 0, or they could both be equal to 0. So what we're going to do when we're solving by factoring both factor, we're going to set each of the individual factors equal to 0, and then we're just going to solve for x. So if we were to solve for x in each of these situations, we end up with x is equal to 2 or x is equal to 5. Okay, and that's our solution. So regardless of what the factors look like, we're always just going to set each factor equal to 0. So for number 2 here, x plus 2 is equal to 0, or x plus 5 is equal to 0. And when we solve, we end up with x is equal to negative 2, or x is equal to negative 5. Okay. This third example is a little bit tricky. People make mistakes on this one a lot. So remember, we are always taking each factor and setting each factor equal to 0. So it's really obvious that this bracket is a factor. It's less obvious to people that that 3x is actually also a factor. So remember, we said we always take every factor and set it equal to 0. So we'll have 3x equals 0 or x plus 12 is equal to 0. Okay, and then we're still just solving. So in this case, we'll just divide both sides by 3. X is still equal to 0, or x is equal to negative 12. Okay, so even if it's not in a bracket, even if there's not a plus or minus, it's still a factor. Make sure you include it. Otherwise, you're losing half your answers. And then for the last one here, number 4, same thing. Our answers are just going to end up being fractions, but we follow the same steps. So each factor is equal to 0. So 2x minus 1 is equal to 0, or 5x plus 3 is equal to 0. And then we solve. So it's just going to be a two-step solve instead of one. So 2x is equal to 1, which means x would be 1/2, or we end up with 5x is equal to negative 3, which means x is negative 3 over 5. So we could end up with fractional answers as well, which is totally fine. Okay, so that's how the zero product property is going to come and help us with our solving. What we're now going to do is we're going to have to start from original equations. We're going to have to factor the equations ourselves and then also use the zero product property to solve. So we're going to be essentially combining what we did last class with what we just covered just now. Okay, so this example is telling us to determine the roots of each quadratic equation, and then we're also going to verify. So remember, every time we go to solve, we have to make sure that one side is equal to 0. So double check you have equals 0. Once you have that, since we're solving by factoring in this section, we're going to start factoring. So for A, there is no common factor, so we can't common factor anything out, which means we're going to jump to our trinomial factoring. Because the a value is 1, we have to have an x in the front of each set of brackets. And then we're looking for two numbers that are going to multiply to 9, and they're going to add to 6. So take a minute and think about it, but it would be 3 and 3. So we have x plus 3 equals 0, x plus 3 equals 0. So that's the factoring bit. And then we just would take each factor and set it equal to 0. Right? And because they're the same, we end up getting the same answer from each of them. So we end up getting x is equal to negative 3 and x is equal to negative 3. Now we only have to write it once because there's only one actual solution, just negative 3. But I'm just showing them both to you so we can see that that's what happens if both of those factors end up being the same. Okay. If we want to verify, we can do a pretty quick check. These answers that we're getting, they're the roots. And remember we said before, the roots happen where the zeros are. In chapter 3, we learned that the zeros are the values that make our function equal to 0. So what we're saying is that if we take this negative 3 value, we substitute it into our original equation for x, we should end up with a value that is equal to 0. Right? Which is what our original equation was set to, was equal 0. So we end up with 9 minus 18 plus 9 equal to 0. So we do our left side, right side check in our equation, and it's true 0 is 0. So we know that we have the correct answer there. Okay. Let's do another. So again, double checking for the second equation here. We have one side equals 0, which is good. Now we're going to factor it. So we need to factor, we need to get 2x squared. The only way to get 2x squared is a 2x and an x. So we know we're going to have 2x and 1. And then the numbers need to multiply to negative 5. So it's either going to be 1 and negative 5 or 5 and negative 1. Okay, because we're dealing with prime numbers, it makes it a little bit easier. So let's just do our trial and error, right? So they multiply to 2, they multiply to negative 5, that's good. We have to check the part where we multiply across. We end up with 2 and negative 5, which adds to negative 3, but we wanted negative 9, so that's not good. So let's try and switch spots with those. Put 1 and negative 5. Then when we multiply across, we get negative 10, positive 1. When we add those, we get negative 9. And that is what we wanted. So our first bracket is going to be 2x plus 1. Our second bracket is just going to be x minus 5. Okay, so we factored it. We know that those two factors have to be equal to 0. So 2x plus 1 is equal to 0. Same with x minus 5. So 2x is equal to negative 1, which means x is negative 1/2, or x is equal to 5. So this time we happen to have two different answers because we had two different factors. So when we have two different answers, we can still check our answers. We can still verify. We're just going to have to verify each answer separately. So 2x squared minus 9x minus 5 equals 0. So we're going to substitute in our values. over x. So it ends up being 2 times a quarter plus 9/2 minus 5 is equal to 0. So it ends up being 1/2 plus 9/2, which is 10/2. And 10/2 is actually just 5. So we end up with 5 minus 5 equals to 0, which is true. So that tells us that that first solution is correct. And then we're just going to do the same thing with our second value, which was 5. So 2 times 5 squared minus 9 times 5 minus 5. So 5 squared is 25. 2 times 5, 25 is 50. Minus 45 minus 5. So we get 50 minus 45 minus 5, which is 0. And again, we get 0 equals 0. So we've double checked now both of those answers are correct. Right? So that's the nice thing about solving by factoring is you can always substitute back in. You can always double check your solution. And at the factoring step, if you're unsure if you factored properly, you can always multiply out like we did last class, and you can make sure that you factored properly. So there's lots of spots in there to double check and make sure you're on the right track. Okay. One thing we can do if we switch direction a little bit is if we know the roots of a quadratic equation, we can actually work backwards to create the equation. So for this example, we know the roots of the quadratic equation are a third and -2. So we can work backwards to write a possible quadratic equation in standard form. So what I'm going to do is I'm literally going to start at the end. Normally we start with the x equal or end with the x equals. I'm going to start with it. X equals -2. Okay. And then what I'm going to do is I want to get one side equal to 0, so I'm going to start moving things over. So if I add 2 to both sides on the left, I end up with x plus 2 is equal to 0. And on the left-hand side, there's a couple ways I could do it. I could either subtract a fraction, or I can multiply by 3 first. Then I get 3x is equal to 1. And then I can subtract 1. So it's up to you which way you do it. There's not really a right or wrong. You'll end up with the same answer at the end no matter what. So if I know that 3x minus 1 is equal to 0 and x plus 2 is equal to 0, then that tells me that these are my factors. So working backwards again, I'm going to write them as 3x minus 1 times x plus 2 equals 0. So that's the equation for the quadratic equation, but we wanted it in standard form, which means no brackets. It also means no fractions. So if you chose, if you do a question like this and you choose to do like, instead of what we did over here, to get 3x minus 1, you might just do x minus 1/3. You have to remember that there's no fractions allowed in standard form, so you'd have to get rid of it later. Okay, but what we're going to do is we have brackets in this. We don't have to worry about fractions because there aren't any, but we do have brackets. So we're going to have to multiply everything out to get rid of the brackets. So we end up with 3x squared plus 6x minus x minus 2. And then we can combine like terms to get 3x squared plus 5x minus 2 equals 0. And then this is our standard form equation there. Okay, so essentially what happens is normally we're used to going this way. We start with the equation and we solve. If we're given the roots and we're asked to find the equation, we're just working backwards. Okay, so that's one type of question you can expect to see. And then another thing we can see here is just like a type of word problem. So we're going to do 2 word problems for the rest of the notes. The first one here tells us that the path of a Jack Russell Terrier on a particular jump can be approximated by the quadratic function h of d is equal to negative 3 over 10d squared plus 11 over 10d plus 2, where h is the height above the surface of the water and d is the horizontal distance the dog travels from the base of the dock, both in feet. So we want to determine the horizontal distance of the jump. So what I'm going to do is the picture we have is adorable, but it's not really showing us what's going on. So I'm just going to draw a picture here. So we have our little dock that he's jumping off of, along with the water. And then we have our doggy, and he jumps like this, so it follows the parabola. Okay. So the height is the height above the surface of the water. So when he touches the water at this point, we know that our height is equal to 0. That's going to help us with our equation because I'm just going to rewrite it here. Right now, we have h of d, so we have function notation. Remember, we always have to have one side of the equation equal to 0. Well, what we're trying to find here is when h is 0 at this point where the dog splashes and hits the water, we want to find out what is d equal to, because that'll tell us the horizontal distance. So since we know that the height is going to be 0, we're going to just take that, we're going to substitute it in for the height in the equation. Okay, so now that we have one side of the equation equal to 0, now we can go about solving. What I'm going to do is, because we have these fractions, remember if we can get rid of fractions when we're trying to solve, especially by factoring, that's so much better. So what I'm going to do is, if I have a 10 in the bottom of each of these, I'm going to just multiply every term by 10. So every term on the right as well as on the left is going to get multiplied by 10. What's going to happen is the 10s are going to end up canceling out, and we'll get rid of our fractions. So we get 0 is equal to negative 3d squared plus 11d plus 20. Okay. And then remember, I also said I like to have my a value be positive because that makes life easier as well. So I'm just going to divide everything by negative 1. So I get 0 is equal to 3d squared minus 11d minus 20. And then that'll just make it a little bit easier for me to factor. Okay. So when I go to factor, so we need it to be negative 11. So that would give me minus 15 plus 4. Okay, so we end up with 3d plus 4 times d minus 5. And then we're just going to set those equal to 0 individually. So 3d plus 4 is equal to 0. D minus 5 is equal to 0. And we'll just go up here. So 3d is equal to negative 4, which means d is equal to negative 4 over 3. Or we end up with d is equal to 5. So because we have a word problem and there's an actual situation happening, we have to go back and we have to look at these these answers in terms of the context of our question. So if we go back and we look at our picture, we have to ask ourselves, D is the distance from the dock. So if we're right at the dock when the dog takes off, this is actually where D equal to 0 happens. Okay. So for the point that we're looking for over here, we have to ask ourselves, does it make sense to have a positive 5 or a negative 4/3? Now, because it's a distance, we really do have to have that positive 5. So we know that D is equal to 5 has to be our answer. However, it's always good to think of where that negative comes from. And what it actually is if we take the parabola and we were to extend it backwards, there would be a point underneath the platform where that parabola would end up again touching the water. Okay, so this parabola here, this is where our negative 4/3 comes from for our D value. But that situation doesn't actually exist in the context of the question, so we're just going to throw that value out. Okay, so anytime you have a word problem, you have to make sure that you're not just going with the answers you get, that you're actually checking them in terms of the question. So to determine the horizontal distance of the jump, so then that tells us that the dog jumps 5 feet. Okay, which is our final answer here. All right. So that's an example of a word problem. It was a really good example because we got rid of the fractions and the negative, but the equation was given to us. So in this last example we're going to again have a word problem, but we're going to have to create the quadratic equation ourselves. So for the last example, it says the length of an outdoor lacrosse field is 10 meters less than twice the width. The area of the field is 6,600 meters squared. Determine the dimensions of the outdoor lacrosse field. So because it's rectangular, dimensions means we're going to look for both the length and the width. Okay, so what I'm going to do, I'm just going to sketch a picture here because the pictures are always really helpful when we don't have one. So we just have our rectangular field. It says the length is 10 meters less than twice the width. So let's let W be our width. And then we can label that W. And then it said that the length is 10 meters less than twice the width. So we're going to take 2 times the width and subtract 10 from it. Okay, and that would be the same on both the top and the bottom sides. So that's good because we have to have only one variable. So if we can write the length in terms of the width, it gets rid of that L variable, keeps us with the W. And then the last thing we know is that the area is 6,600. So that area piece is actually what we're going to use to create our equation. So because it's a rectangle, area is length times width, but we can substitute in what we know. So we know the area is 6,600. We know the length is 2W minus 10, and then the width is just W. Okay, so now we have a quadratic equation. Now we can solve this by factoring to get our answer. So remember, before we factor, one side has to be equal to 0. And we always factor from standard form too. So there's a few things we need to do. We need to get rid of these brackets, and we need to move everything over to one side. So do the brackets first. We have 2W squared minus 10W. And then what I'm going to do is, since the 2W squared is already positive, I'm going to move everything over to the right-hand side, and that way it will stay positive. So we have 0, is 2w squared minus 10w minus 6,600. So now one side is equal to 0, the other side is in standard form. So now we can start solving. I noticed that we have a common factor of 2 here with all our terms. So I'm actually going to divide everything by 2 to help get our numbers smaller. So we end up with w squared minus 5w minus 3,300. Okay, so now we're going to factor it. So we need to find two numbers that multiply to 3,300 that are 5 units apart. Okay, so that would be 55 and 60. So if we go plus 55 and minus 60, that would end up giving us the minus 5w, so that's great. Take each factor, set it equal to 0, and then solve. So w equals negative 55, or w equals to 60. So again, because this is a word problem, make sure you're going back and checking your answers. So we said that w is the width. So we could have a width of negative 55, or we could have a width of 60. Now it makes no sense to have a negative width, so we're just going to get rid of that answer right off the bat. That means that our width is 60, but we were originally asked to find the dimensions. So remember we said that was length and width. So we know the width is 60, we need to find the length. So we can take this equation, the 2w minus 10, to find the length. So length is 2w minus 10. So 2 times 60 minus 10. So it is 110. And our units were meters, so we should just throw our units on these as well. So it's 60 meters by 110 meters. Okay. All right, so that is solving by factoring. There are a bunch of textbook questions for you to do. There's also a solving by factoring worksheet, which is on the next page. So I'd like for you guys to do both of those. The solving by factoring worksheet is not like word problems. It's all just basic factoring, as you can see. So that might actually be a better place to start. The answers are there for you, and then maybe move on to the textbook questions afterwards. Okay, but do your best to get those both done. Remember, factoring is important not just for this chapter, but also for our future chapters.